Another feature that you'll notice on these frames is a bit different. We talk about our energy efficiency programs. We actually use these flat 2x6s instead of 2x4s. Like normally a T would be boxed in. This is called a T, this intersection between the interior wall and the exterior wall. It would be boxed in. There would be a void back here that you couldn't insulate, which hurts the insulation value of the wall. So we actually do this on flat, and it allows us to get insulation behind here. When we blow up, we're going to take you to an insulation job and show you what that looks like. But this is one of the energy features that we do that you'll see in our houses that may not be in the competitors' houses. The other thing is the radiant barrier. I'm sure you're probably all relatively familiar with that. The general principle there is it won't allow the heat to penetrate the roof, and it actually reflects, I think, 93% of the heat. So the heat energy coming from the sun, which keeps the attic about 30 degrees cooler, helps your AC bills, makes the house more efficient, and reduces the tonnage necessary to keep it cool. So it's a good cost measure. It's actually something we do to provide benefits to the homeowner, and that's going to be there forever. So it's something that they don't have to maintain, and it's easy for them to deal with. Does anybody have any questions specifically regarding the frame, how we do things, anything that's come up?
I know in my area, like, there's a whole lot more strapping than what I'm used to seeing.
Absolutely. There are different wind zones, and these rafter ties up here, those are Simpson H2.5As. This is our kind of low wind standard to have these on every rafter, and then I believe you're at 4-foot centers here with 5/8 anchor bolts. So we have a prescriptive method, is what it's called, where we follow these specific wind designs for under 110 miles an hour, 110 miles an hour, 120 miles an hour, 130 miles an hour, 140 miles an hour. So depending on the community you're in, those details are going to vary, but they're very specific to that area. Because inside of the same parish, you may have multiple communities that have different wind zones. So that's something that you don't want the homeowner to get hung up on. If they start questioning it, say, well, we designed for whatever wind zone the community's in. If the community is in the same parish, it may be in a different wind zone.
Do you know the wind zone for my area?
I'm not certain what it is, but I think you're probably in 120.
I think it's 130.
No, 130 over there.
I don't know who's down there.
Yeah, I definitely think you're 120 above. So you have header straps probably.
Oh, there's like,
yeah,
there's double straps here.
Yep.
And then there's double straps down here.
And that's going to be something that's going to be different. Like
each corner has straps to the slabs.
Yeah. And they're on the insides.
Yeah, they're on the outside.
Okay.
Because it's post tension and they're coming out.
Yeah. 14.
Yeah. So we have there again some different details. In Gulfport, they actually have straps on the insides of these studs and bolts that go down into the slab right there instead of having the exterior straps. So just from area to area, that's going to vary. But just the answer basically to the homeowner would be we have specific wind guides for every subdivision, and that's something that's on each plan, and we put it in with the inspection process. So they definitely look at it.
I have a question, Ron. Every now and then I get the homeowners where their grandpa comes to the house and they're like, y'all don't put plywood on the insides of the walls? And I'm like, well, my answer to it is I tell them, I was like, I really think it's pointless, because I'm sure through the years they found out that the home that had the plywood inside the walls was just as sturdy as the one that didn't and survived the wind,
Right.
So I think they know what they're doing now.
So the plywood on the interior wall would be what's called an interior shear wall. There are some instances where you would need that. We have engineers look at our plans, and we don't have any requirements for that as of right now. So that is something at some point you may see in a house that we build, but it would be plan specific, and there's a certain standard that they follow as far as how the house is cut up in separate boxes in effect, depending on how the footprint looks, and that defines whether or not they need interior shear walls. So they may have seen that in some houses. That may be an over-engineered house, or maybe a different design that is actually requiring an interior shear wall. But as of right now, we don't have any plans that have interior shear walls.
Plus, the windstorm OSB we use is not the stuff you pick up at the local hardware store and wrap the house with.
Yeah, that's a unique feature, and it's actually an energy efficient feature. So if you see this, is called OSB. It's oriented strand board. It's basically what they started using after they figured out plywood was not that strong. Like plywood's strong in one direction, but it's not strong in another direction. This OSB is as strong in each direction. So it's actually a better product than the plywood or CDX that they'll call it. Some of the old timers will say, oh, y'all not using plywood. Well, plywood's more expensive and it's not as strong. And if you use it normally, you have 4x8 sheets, and that goes sideways, and you cross block it so you can nail it in. And they'll actually have seams running all over the house inside of this OSB. Well, those are cracks in your house that allow air to get in and require more heating load and cooling load during those seasons. So this actually helps seal the house up better and make it a tighter building envelope. I don't know if you've seen that term in our pamphlets, but basically that's part of that push we have. So try and seal the house up as best we can, because the more air you move in and out, the more you have air conditioning heat. So we try to seal the house up. Not to mention, this actually makes the house significantly stronger because it's tied into the top plate and the bottom plate. So for this house to move, it has to basically rip apart this piece of wood that goes from the top to the bottom instead of something that has a hinge in the middle. So this is actually a much stronger way to build the house, and it actually costs quite a bit more. So we're not required to do this. It's something we choose to do because it's a better product and it's a better process for us as far as infiltration goes. So, you know, we really kind of value engineer the houses as best we can, and this is one of the things where we've decided to spend some money. So this is probably a differentiation thing. If they bring that up, say, yes, but we do this, this is something probably the other builders aren't doing there, because not a tremendous number of them do.
So the seams are meeting in between two.
The seams will split out over the stud. So yeah, you'll have basically half on this side, half on the other, and you don't ever see the seam. Versus having a seam here, and probably on the 9-foot wall, you'd have two seams. Because you'd have 4 foot, 4 foot, and 1 foot, or 2, 3, and 4, depending on how they broke it out.
So this is a 9-foot.
It's a 9-foot plate, and it's straight. Yeah, it goes from top to bottom. So it's called windstorm board, and that's actually a good feature to point out if they have questions about wind zones, because that is a strength thing. We do kind of above and beyond code. Is everyone familiar with the terminology as far as these are studs? This is going to be called a mud sill. This is a header over the windows. Those are joists that make up the ceiling. The roof is made up of rafters. And then the OSB on the roof, which is actually the tech shield, it's OSB with foil on the bottom of it. That's called decking. So that's the basic terminology of the framing components. And then there's the T's and corners and things like that. But for the most part, that's probably all you'll ever need if they're pointing at something. If you get somebody who has a little bit of construction knowledge and they start saying, well, why'd you do the header like this or something, then you'll know what they're talking about a little bit. We actually do full headers over all of our windows. We had gone to the ladder headers over non-load bearing walls for a while, but we've pulled back off of that. These are all on 16 centers. So currently you may get some people asking, well, you know, are these on 24-inch centers or 16-inch centers? These are 16s. We only build on 16-inch centers. We may eventually go to 24s because they're okay. That's perfectly fine as far as code is concerned. It can cause some waviness with sheetrock if you don't do it correctly. It just exposes you a little bit more to that, and that's something that, you know, people might ask you, are these standard width, which they are, which is 16 inches. So that means these studs are 16 inches apart. If you measured from the center of this stud to the center of this stud, it's 16 inches. Some people do 24 inches on center, which looks a little wider, which is, there again, it's fine, but you know, it's something where we put a little bit stronger wall up, and it's a differentiation point, because I don't know if there's any builders in any of your areas that are doing that, but that's one of the advanced framing.
There are some that do 24s on the.
These are all 16s as well. So we do 16s on the joists and 24 on the rafters. So that's something else. If they hang the wrong sheetrock up there, if they put half-inch sheetrock that's not span rock or 5/8 inch thick, it can actually cause waviness in the ceiling, and that's something we don't want to expose ourselves to. That's actually called a strong back. You see that piece running horizontally across the ceiling joist? That's to help tie all these together into one system, to keep them from having highs and lows. So they actually nail those two boards into the top of each of these joists, and it should keep them in plane across the ceiling. So that's another thing we do to try to make sure we have really laser straight ceilings, is we put those strong backs over each span. These are the joist hangers that we use. Those are actually to help hold the joists up when they butt into a beam. So that's something else that you'll see as far as hardware goes, the metal in the house. That should be pretty consistent from wind zone to wind zone. Realistically, the strapping over the headers you mentioned, the corner straps, the spacing of the anchor bolts, the sizes of the anchor bolts, which are these. They're holding this mud sill down in the concrete. So these have a little L hook on the bottom, and they embed them in the concrete when they pour it, and then they'll come back and put either a flat square washer or these round washers, and this will be either a 1/2 inch or 5/8 inch bolt depending on the wind zone. So that's another variant you'll see. in different areas, is they'll be either closer together, bigger, smaller. So there's some variation there, but you know, nothing they should be worried about, because whatever it is, it's applicable to the area the house is built in.
I have a question.
What's up?
One of the houses that a buyer was looking at, the stud, the stud was kind of not straight up and down.
Okay.
And it was a little off. So he was very concerned about that. Is that something to be concerned about?
It's not a tremendous concern. Probably when he was laying out, he put it on the wrong side of the line. So the most it was probably out is like 1.5 inches.
Okay.
And some people go 24 inches on center. So at worst, he was at like 17.5 on center, which is perfectly okay. Not that it should have been done. Some other times you'll see them doubled up when they cut into the stud. So have you ever seen in a frame job, they've cut into the stud? So what they'll do is they look down these walls to make sure they're straight. And just like those ceilings, we want them to be very straight so they look good. Well, they'll cut into this stud and actually put a stud next to it and nail it in. And that's them repairing one that has a bow, because as the wood dries, it tends to bow and curve and twist. Well, they check for all that during their frame punch. And they'll actually do what they call saw kerf it. That's where they cut the stud with the saw. So they'll take the saw blade and it puts a little gap in it and allows them to actually straighten that stud out. And then they'll stick another one next to it for structural purposes. Because anytime we notch the studs like that, we need to put another stud next to it.
But this would be caught at the very end
At
of
the frame punch. See, they framed this house. Their superintendent's going to check it. And he's going to say, yep, it's good. And then he's going to give the form to Robert. And Robert's going to come in here and check it again.
Okay.
So it's getting checked a lot. So they're checking it, then we're checking it, and then we're actually coming in at QC and making sure the walls look straight and everything else. So we're checking everything multiple times during the process to make sure nothing gets through.